Hello students, today we start next unit of physical chemistry semester 5, that is nuclear chemistry. This is a special unit for 15 marks, compulsory questions for 15 marks, and with option there may be 25 to 30 marks in your question paper, one independent question and one mixed question, that is objective type question. See here, nuclear chemistry is a very important branch of chemistry and related to atomic energy. Nuclear chemistry is related to atomic energy. That is one of the most important application of nuclear chemistry is atomic energy. We know that simple reactions, if we consider, which are organic reactions and many inorganic reactions that are related to breaking and formation of chemical bonds in molecule. In that simple reaction, nucleus of the atom in molecule not participate. But in this case, in nuclear reactions, in nuclear chemistry, that bonds breaking and formation, that is not matter. Nucleus of atoms in molecules are participate, that involved in nuclear chemistry, in nuclear reactions, and in that radioactivity property that is related to nucleus only. Therefore, that compound, if we consider radioactivity of uranium, then uranium in any form, that is, if that may be pure or that may be in combined form, that purity of that substance is not matter, that not depends on, that not affects on radioactivity power of that atom. Only factor is amount of substance, amount of that substance, amount of that atoms in that matter. That related to this nuclear chemistry, Henry Becquerel in 1869 discovered this property of, or this phenomena of radioactivity, which is very important and lead to development of atomic energy as the richest energy source known to man. This is richest radioactivity that leads to atomic energy and which is the richest energy source known today. And that we already known that many energy sources like that fuel that maybe that are exhaustic, and therefore in future this one be the important source of energy. Now also this is important source for energy, future also, and now in present also atomic energy as a important source of energy. Related to this nuclear chemistry, Madame Marie Curie, her husband Professor Pierre Curie, daughter Irene Curie, and son-in-law that son-in-law Juliet, that four members of same family awarded Nobel Prize for their research in the field of nuclear chemistry, that is radioactivity. Four members, Madame Curie, husband Pierre Curie, daughter Irene Curie, and son-in-law Juliet, that four members of same family awarded Nobel. Then what is radioactivity? What is radioactivity? See definition of phenomena of radioactivity. The phenomena of spontaneous emission of radiations. The phenomena of spontaneous emission of radiations similar to X-ray. That radiations are similar to X-ray, that is highly energetic radiations, that could ionizes the medium which it passed. This was termed as natural radioactivity, because this is spontaneous phenomena, therefore natural radioactivity. What is definition? See here again, the phenomena of spontaneous emission of radiations similar to X-ray. The phenomena of spontaneous emission of radiations similar to X-rays that could ionizes the medium which it passed. That we could ionizes the medium that could pass. That could ionizes the medium which it passed. This was termed as natural radioactivity. Remember this. This one is spontaneous phenomena. Itself occur. No any external force required. Therefore, that substance itself emits that radiations. Therefore, phenomena of spontaneous emission. This is spontaneous emission. Then type of radiations that substance emits. If we carry out one experiment, that is a narrow hole drilled in lead box, in lead block, and small amount of radioactive substance is when placed at the base of that narrow hole, then that radiations emitted are that observed of three types. If magnetic field is applied and that radiations are passed through it, through that magnetic field, then it is observed that some radiations deflected towards positive terminal, some deflected towards negative terminal, and some radiations remains undeflected in that magnetic field, magnetic and electric field. Then that radiations which deflected towards positive, that positive terminal of electric field, that our deflection is more as compared to deflection of that negative terminal of electric field. Then depending on that, radiations which deflected towards negative electrode that are positively charged, that are known as alpha rays. Those are deflected towards positive electrode that itself are negatively charged, and that are known as beta rays or beta particles also, and which remains undeflected, that are known as gamma rays. Thus, that radioactive substance emits radiations of three types: positively charged, that are called alpha rays; negatively charged, that are beta rays; and chargeless, that are gamma rays. Then if we discuss properties of that radiations, alpha, beta, and gamma rays. First, we discuss properties of alpha rays. Alpha rays deflected towards negative negative electrode in electric field. Therefore, that means that are positively charged. Alpha rays are made up from helium cations, that is He plus plus ions. He plus plus ions. Helium, if we consider, is a that molecule, atomic molecule, single atom, mass number 4, atomic number 2, 2, 4. If we consider simple atom, then in nucleus, 2 proton, 2 neutrons. 2 protons, 2 neutrons. Therefore, mass number 2 plus 2, 4. And in neutral atom, 2 electrons revolves around that nucleus. Therefore, charged balanced. But if we remove that electrons from helium atom, then what happen? Only nucleus remain. Only nucleus will remain. But electrons are weightless. Therefore, no effect on that mass number of helium by removing that electrons. Therefore, that mass number same. 2 neutrons, 2 protons, therefore 4 mass number in nucleus. Therefore, by removing that 2 electrons, what is the situation? He plus plus, He plus plus. That alpha rays are nothing but that are formed from helium particles having mass number 4 and atomic number 2. Mass number 4, atomic number 2, and unit positive charge. 2 unit positive charge. 2 unit positive charge. That is He plus plus. He plus plus. That are alpha particles travel straight line through air. Travel straight line. That particles are massive particles, heavy particles, and therefore travel straight line in air. Their at emission point velocity of that emitted alpha particles is about 5 to 10% that of velocity of light. That is less velocity compared to beta and gamma rays, because that are heavy particles. That alpha rays, because of their heavy and large size, and because of their weight, that alpha particles have maximum ionization power. That medium through that passes, that alpha particle ionizes that to that medium. Therefore, that have maximum ionization power because of large size. And because of large mass, alpha particles have least penetrating power. Penetrating means passing power. If obstacle is there, then that passing through that obstacle, that is nothing but penetration. That penetration power, because of large size, is less as compared to beta and gamma rays. And the range of alpha particle depends on source, and it is up around 2.8 to 8.6 centimeter. They travel only from source only this much distance. These are properties of that alpha rays. Remember that. Then beta rays. Beta rays deflected towards which electrode in electric field? That is deflected towards positive, means that our self are negatively charged. Beta rays are nothing but made up from beta particles. that is beta particles is nothing but electrons. Beta particles are made up from electrons that are nothing but beta rays, that is electrons that are formed from electrons. Alpha rays formed from He++. Same way here, beta rays are nothing but electrons that are, and therefore electrons carry unit negative charge. Beta particle electrons are weightless. Therefore, beta particles travels in a zigzag path through the air. They travel zigzag path. Velocity of beta particles is almost 99% as the velocity of light, which is very large as compared to velocity of alpha particles, because that are heavy, therefore velocity is less. But here beta particles velocity is 99% as a velocity of light. Then due to small size, ionization power of beta particles or beta rays is less. Ionization power of beta particle is much less than alpha particles, and due to its small mass, penetration power is more. That are, penetration power is of beta particle is about 100 times greater than alpha particles. 100 times greater than alpha particle. Because of small size, penetration power is less, and ionization power is less and penetration power is higher. Ionization power is less, small size, because of small size, and penetration power is about 100 times greater than that of beta particles. Then next, that rays which remains undeflected in electric and magnetic field, that are nothing but gamma radiations. That gamma radiations, that are only electromagnetic radiations, that are not a particle nature, only that rays are electromagnetic radiations similar to X-rays, electromagnetic radiation similar to X-rays, and remains undeflected in electric and magnetic field, means that are chargeless. Only electromagnetic radiation similar to X-ray, highly energetic. Gamma rays have more energy than X-rays. X-rays more energy than X-rays. Gamma rays have very less ionization power, and gamma rays have very high penetrating power, which is more than that of alpha and more than beta also. Penetration power is very high and ionization power is very small compared to that alpha and beta. These are four properties of that gamma radiations. Remember that gamma radiations are electromagnetic radiations similar to X-rays and remains undeflected in electric and magnetic field. Gamma rays have more energy than X-ray, and gamma rays have less ionization power and more penetration power. Okay, tomorrow we discuss behavior of ion pairs in an electric field. Thank you. We stop here.